In the name of God. Hello, dear students. Welcome back to Ferkhwaz website. My name is Masoud. I'm a physics teacher. We are here to explain physics curriculum, grade 12. Actually, here we have a goal to explain the physics and let's say in an easy way. And we try to make physics easier for you as much as possible. So this subject is a new subject regarding the chapter 2. So far we explained some subjects about chapter 2. Right now we are going to explain new subject which is very significant in chapter 2. This let's say subject is dedicated for torque, right? Torque is a new word for us. We haven't been familiar with torque yet, actually. We don't know what torque is, right? But right now we are going to, let's say, to get some information about the torque. And the title of this subject is the magnitude of a torque. Magnitude of the amount of the torque. Let me define the torque for you, and after that, I'll explain it for you. Definition of torque. What's the meaning of torque? Torque means a quantity, so it's a physical quantity that measures the ability, it measures the ability of a force to rotate an object around some axis. So torque is a quantity that measures the ability of force. It measures the ability of force to rotate an object about some axis. So I underline two things. I underline torque and rotate. Torque and rotation. They are associated with one another. Whenever you hear the word torque, means there's rotation. Simply we can say torque means rotation, right? Like what? Teacher, could you give me an example about the torque? Yes. For example, there's a bottle of water. Whenever you open the lid, you use torque because you rotate the lid, right? Whenever you open it or you close it, actually, in these situations, so you use a torque. You use a force. Does this force has ability to rotate the lid? Yes. That's why the force has a torque. So any rotation means, let's say, any rotation has to do with a torque. So torque is responsible for rotation, right? So let's say, creating any torque or acting any torque on an object needs two things. Firstly, we need a force, right? And secondly, we need let's say, a distance from we need the force firstly, and after that, this force should be, let's say, should be acted on an object at a particular distance. So we have two things, force and distance. Force multiplied by distance becomes torque. Simply, we can say this, let's say, the product of force and distance is called torque. Torque, or I can say force is not enough for acting torque on an object. Force is not enough to rotating object about itself, for example. So a force, let's say, and distance together can rotate an object, right? Force and distance. Without distance, force, let's say, does not have any ability to rotate an object, right? So force and distance together, producing of force and distance, simply we can say it's called torque. There are a lot of examples about the torque. For example, I've brought, for example, a spanner for you. This spanner, and there's a screw. We wanna, let's say, rotate the screw. We wanna turn the screw, right, by means of a spanner. Whenever you rotate the, let's say, you rotate the screw, in this situation means you use a torque. Yeah, right? You use a torque whenever you rotate the screw. So let's say loosen or fasten the screw needs a torque. And torque is created by what? By two things. by exerting force on a screw from a particular position, right? Exerting force from a particular distance. You see, I exert force, let's say on a screw, on top of a screw here actually, and from a certain distance. This distance matters actually. Without this distance, a screw does not rotate. So we apply, or I can say we act torque on a screw by means of a spanner. One more example, or actually there are a lot of examples if you think about, let's say, our daily life. Actually, there are plenty of examples regarding the torque. For example, about a pet. There's a pet here, and there's a cat flap door. This door is suspended, right? It's suspended from two hinges. The cat can, let's say, enter and let's say exit by exerting force on a particular position from the hinge, right? There are two hinges here. The pet, for example, by its nose or by its head, by its any part of its body, exert force on the door, and cat flap door can enter and let's say can open and close, right? And cat can enter and exit by means of a force. So force acts on a door from a particular position, right? From a particular distance. I can say the distance between force and hinges is called lever arm. So from now, I want you to memorize this word. Lever arm is the distance. So it's a professional word for distance, right? I told you, force lonely is not enough to creating torque. That's why force and distance together matter, right? And the axis of rotation of a cat flap door is important. Teacher, what do you mean by axis of rotation? I mean, it's a line that passes through the hinges. It's a perpendicular line that passes through the hinges. This is called axis of rotation. So this is axis of rotation, right? Does this line pass through the hinges of a cat flap door? Yes. That's why this is called axis of rotation. So distance from an applied force to the axis of rotation is called lever arm. This distance is called lever arm. So force and lever arm together can make torque on an object, can act torque on an object. For example, this is let's say model of this figure, right? We have an axis of rotation. We have an axis of rotation. This axis of rotation is hinge of the door, hinge of the cat flap door. In this situation, and this is a nose of a cat, for example, it applies force to this position exactly. That's why the door, let's say, rotates about itself in this situation. So can I say the pet, let's say, acts torque on a door or not? Of course, it acts torque on a door because it rotates the door. And rotation, let's say, does not have to be a full circle actually, right? It mustn't let's say a full circle. Any, let's say, any motion, let's say, is considered to be a rotation. Maybe the torque only, let's say, is taking place across a small curve, a small, let's say, arc length, right? And sometimes the arc length is very long. Sometimes the arc length is the full circle. So keep in mind that torque, let's say, must not be a full circle or full cycle. Sometimes only a small arc is taking place by means of a torque, right? So anyway, this is called This is called torque, and keep in mind that torque means rotation. The distance, the particular or perpendicular distance from the hinge to the applied force is called lever arm. Axis of rotation of any door is a straight line that passes through the hinges of a door. So we have axis of rotation. Let's say define axis of rotation for you. It says axis of rotation of a door is a line that passes through the hinges of the door. I told you actually. I explained it for you. It's a line that passes through the hinges of the door. One more, let's say, question about the axis of rotation. For example, we have this door, right? We have a door. It's not like a cat flap door. It's like an ordinary door for our houses, especially in our rooms, and we use these doors. Actually, there are two hinges, right? I want you to determine, and there's a knob. There's a door knob actually. You apply force on this position. So this is a, let's say, force, applied force, and this is doorknob. I told you this part is a doorknob, right? Doorknob, and they are hinges. I want you to determine the axis of rotation, right? What's the axis of rotation? Let me, based on this definition, axis of rotation is a line that passes through the hinges. How many hinges are there here in this door? Two hinges. And this line is called axis of rotation. Axis of rotation. So, whenever you, let's say, open and close a door, right? Do you apply torque on a door? Do you apply torque to the door, or do you act torque on the door? Of course. Why? Because you rotate the door, and I told you rotation, maybe it's a rotation is taking place only across a small arc, right? A small arc, not let's say not a full circle. In this situation, one more question. I want you to determine the lever arm. The lever arm, based on the definition of lever arm, I'm gonna read the definition. After that, I want you to determine the lever arm for me. Lever arm or moment arm. Sometimes we say moment arm, but very common word is, very common expression is lever arm, right? This phrase is very common, lever arm. It said the perpendicular distance, from the axis of rotation to a line drawn along the direction of the force. The perpendicular distance from the axis of rotation to the what? To the force. Simply we can say to the force, or your book says the perpendicular distance from the axis of rotation means from here till here, right? Your book says to the line drawn along a direction of force. No problem. If you extend the vector of force, it doesn't matter. If you calculate the lever arm from here, from the axis of rotation till the extending of the force, no problem. Or you, let's say you measure the distance from the axis to the force itself, no problem. If you, let's say, measure the distance from the axis of rotation to the force itself, or from the axis to the extended line, let's say, to the force, no problem. If you trace out the force, if you extend, let's say, draw an extended line, no problem. This situation is the same. So determining the lever arm is the distance between axis of rotation and to the line drawn to the direction of force. Or simply we can say, let's say, the distance, perpendicular distance from the axis to the force, that's it. This is lever arm, right? So mathematical form of torque, we have a symbol for torque especially. From now, we use tau. It's not an English letter actually, it's a Greek letter, tau. Tau is calculated, it's, let's say, I want you to read it as tau. Tau is read actually as this letters read as tau, right? And tau is calculated by this equation. Tau is equal to Fd sine theta. This is the mathematical form of torque, right? Tau is equal to Fd sine theta, where tau is the torque, F stands for force, and theta stands for the angle between F and D. So theta is the angle between F and D. And d sine theta represents lever arm. D sine theta together, right? So d sine theta together is called lever arm. That's why, based on, let's say, this equation, we can say lever arm depends on two things, depends on two factors. It depends on the force and lever arm, because d sine theta together means lever arm. Or you can separate the factors. You can separate the factors. You can say tau depends on three factors. It depends on the force. It depends on the distance, let's say from the axis of rotation to the force, and the angle between, let's say, F and D, the angle between force and the distance. You can separate them into three factors, or you can say it depends on two things, on the applied force, amount of applied force, and length of the lever arm. The SI unit of torque is Newton meter. Let me, let's say, drive it for you. Tau is equal to Fd sine theta. So F is measured in Newton. It's clear, right? And D means distance, is measured in meter. So Newton meter is the unit of torque, right? That's it. Note number one, the direction of the lever arm is always perpendicular to the direction of applied force. Let me explain it on this figure. Actually, we want to explain it on this figure. There's a figure here. This figure, let's say, shows a wrench. A wrench, let's say, tends to rotate a nut, actually. A wrench, let's say, loosens the nut here. In this situation, this is the position of force. So the person, whenever the person uses the wrench, right? The person applies a force to this position, to the end of the wrench, right? To the end of the wrench. This is the position of force, this one. So this is F, right? What's this position? The center of the nut, or the center of the screw or nut, actually, there's a nut here. The center of the nut is axis of rotation. This is axis of rotation, right? The force, it says, I'm gonna tell you about the note number one. I'm gonna elaborate note number one. It said the direction of the lever arm is always perpendicular to the direction of the applied force. What does it mean? The direction of lever arm is always perpendicular to the direction of the force. This is the force, right? I want you to extend the force, right? Extending the force, let's say downward. In this situation, this part is lever arm, right? Lever arm. I have a question for you. Is lever arm, this is lever arm, right? This red line is lever arm. Is lever arm perpendicular to the force or not? Yes. Whenever you extend the force, you extend the vector of force, actually it reaches the lever arm, and it cuts the lever arm. It makes a 90-degree. That's why force is perpendicular to the lever arm always. This about, let's say, this one. Maybe you say, teacher, how do you know, let's say, how do you calculate lever arm here, d sine theta? Let me explain for you. For example, the length of the spanner is denoted by d. We say that the length of the spanner is d. This is the length of a spanner, right? and the force acts here. Look here, force acts here like this. I want you to extend the force, right? And what do you say about the third side of the triangle? The third side, because there's an angle between what? Between F and D. This is F, right? And this is D. The angle between F and D, you see, this is the angle between F and D, is called theta. Angle between F and D is called theta. So we look for this side, right? For example, this side is unknown, x. How do you calculate, let's say, x? Can I say sine theta? Look here, sine theta is equal to opposite side divided by hypotenuse or not, based on, let's say, trigonometry. I can say the definition of sine of any angle is equal to the division of opposite side, x opposite side to the angle, divided by the hypotenuse. And hypotenuse is the longest length of a right triangle. I want you to cross multiply this fraction. Whenever you cross multiply the fraction, look here, what do you get? You see that you deduce that x is equal to d sine theta. That's why x, or this part, the base of the triangle, is d sine theta, right? That's why this part is lever arm, right? This is lever arm. So by means of sine function, you can see that you can, let's say, determine that the base of the, let's say, right triangle is a lever arm. Note number 2. The length of lever arm is measured from the axis of rotation to the applied force. So the length of the lever arm is measured from what? From the axis of rotation, which is the center of the knot here, to the force itself, or to the extending of the force, right? Whenever you extend the force, so this distance is called lever arm. Lever arm is measured from the axis of rotation always. A starting point for measuring the lever arm is axis of rotation. Axis of rotation toward what? Toward the force or extending of force. Whenever you trace out the force, right? In this situation, the distance between the extending line of the force and the axis of rotation is called lever arm. Actually, these notes are important, especially for solving the problems regarding the torque. Hint, we have a hint here. If theta is equal to 90 degree, right? If theta, in this situation, theta is not 90 degree. Actually, theta is acute angle. It's acute angle because this angle is not 90 degree exactly. Theta is less than 90 degree. But this note is not for this case actually. If theta is equal to 90 degree, if theta is right angle, it says the lever arm is denoted only by D, right? The lever arm is denoted by D rather than D sine theta. So sine theta is disappeared from the equation. Why? Because sine 90 becomes 1. Sine 90 becomes 1. That's why, let's say, D sine theta does not remain as it is. D sine theta turns to D. Only in, let's say, in the case that, in the case of the force, in the case of the perpendicular force, actually. If the force is perpendicular, or if theta is 90 degree, if the angle between F and D, let's say, is 90 degree. Let me elaborate it for you. Let me erase other parts. I'm gonna, let's say, break down this note for you. It says if theta is equal to 90 degree. Teacher, how do you know theta is 90 degree here? Let me explain it for you. How do you know it's 90 degree? This is F, right? And this is D. Axis of rotation, I told you, center of the nut becomes axis of rotation. So lever arm is measured from here, from the axis of rotation to the what? To the force or to the extending of the force. No problem, it doesn't matter. Right? So this distance is called D. Right. So is angle between F and D 90 degree or not? This is D, right? And this is F. Is this angle 90 degrees? 90 degrees. So in this situation, I can say, let me erase this one. I'm gonna, let's say, draw it from beginning. So this is D. The angle between F and D, this is 90 degree, right? 90 degree. If angle between F and D is 90 degree, in this situation, D sine theta, look here, D sine theta turns to D only. And keep in mind that in problems, sometimes a question does not mention any angle. If question doesn't mention any angle, means the angle is 90 degree. It doesn't need to write D sine theta, just write D. And in this situation, tau becomes FD only, right? So in the case of, let's say, right angle, if the angle between F and D is 90 degree, it does need to write the full form of the equation, tau is equal FD sine theta, because sine 90 becomes 1. This part, let's say sine theta, disappears from the equation, and this sine theta becomes D. Like this figure, actually. In this figure, because the force is, let's say, acted on the wrench, let's say, at right angle, that's why it doesn't need to write the sine of 90. If you write the sine of 90, no problem, but it doesn't need, because sine of 90 is equal to 1. And thus maximum torque is produced since the force is perpendicular. So whenever you, let's say you hear whenever you have 90 degree for theta, and it's the angle between F and D, it means you have tau maximum. So in which situation we have maximum torque? When the angle between F and D is 90 degree, right? And especially, let me give you an example. Whenever you, let's say, whenever you open a door, whenever you apply force to the doorknob, this is the, let's say, this is the convenient angle. This is the best angle to, let's say, to rotate an object. And in this situation, we have maximum torque. And that's it, guys, for today. Thank you very much for watching this video, and bye for now.